Integration of Spot into a symbiotic resilience framework.
Presented is a digital twin which can be used to send and receive commands from a multi-robot fleet. In this case, the Spot quadruped robot, DJI Tello Drone and 3 security cameras.
When the Systems Check button is pushed, the digital twin sends a command to the Spot robot to test its functions. The robot then performs a small autonomous operation to make sure the movement systems are working on the quadruped robot.
The reason we have designed a digital twin for multi-robot fleets is because we are seeing a wide variety of robots being used to complete operation and maintenance. However, there is currently no methodology which exists to manage several robots at the same time.
The digital twin facilitates safety compliance, resilience, and reliability diagnosis to enable safe autonomous robotics for the offshore sector. An autonomous multi-robot fleet mission evaluation centered around resilience, which identifies sub-features within mission profile, environment, robot, and safety, can advance human-robot collaboration for regular deployment of robotics. This will reduce offshore operating costs and duration of inspection.
In the next room, there is a security camera which is used to confirm that the room is all clear before the autonomous mission is started. This allows for cross-referencing with the in-situ camera.
In this segment of the mission, the Tello UAV is teleoperated via the digital twin using an Xbox controller to allow for an overview of the Spot robot to corroborate that it is operating as intended.
During operation, the onboard sensing and monitoring of the drone and Spot are corroborating with the security camera on the status of the mission space.
In instances of constrained line of sight or fault in onboard mapping of the robotic assistant, the safety assurance of the pathway to recovery or to return to home is verified via the camera.
The human operator is using the security camera to ensure the robot is acting as intended. This corroborates with the diagnostic information seen in the digital twin.
The focus pages of Husky and Spot allow for the diagnostic information of each robot to be viewed clearly. This corroborates the state of the robot during the autonomous missions.
There are many types of robots which can be used for several different tasks. Therefore, how we manage and operate these robots is important. Hence, our work looks to deliver on autonomy as a service, where operators can operate, manage, understand, and collaborate with a multi-robot fleet whilst they complete their autonomous missions.
To view more of our video outputs, search Smart Systems Group Heriot-Watt University on YouTube, and please see a link to our latest publication, which outlines our symbiotic system of systems approach for resilient autonomous robotics in offshore wind farms.